Hello everyone, welcome to today's session which is about 7 fundamental principles of testing. So let's begin. So there are a few principles which we have to understand when we are actually working as a tester or when we are doing testing over any software. We learned about the basics of testing, objectives of testing and few terms in the previous session. Today we'll focus on few principles which are important to be known before you actually start working. Now, so let's start with the first principle, which is testing shows presence of defects. So I've created some notes for you to understand the principles better. So what does the first principle mean? Is that testing will find out defects, but it cannot prove that there are no defects. So even if you do 100% a lot of testing, you cannot be assured that the system is 100% defect free. So the first principle is related to the second principle. We'll talk about it. But here you have to understand that testing will only show that, okay, there is defect, but you cannot be assured that, yes, there is no defect, even after doing a lot of testing as per you. So that is the first principle of testing. Now, second principle says exhaustive testing is impossible. Yes. You cannot say that the system is 100% bug free. Even if, let's say, there is some 20 fields in a form and each can have some 10 test data. You cannot just apply all the permutations and combinations because your project timelines won't allow you to perform testing on one page for so long. So you have to understand that exhaustive testing is not possible. The aim should be to have a system which is bug free and which is perfect. But even if there are minor issues left in the system, we have to move forward sometimes, and we cannot be assured that yes, the system is bug free or 100% bug free now. So that's the second principle. And the third principle says early testing. This is a very important concept, guys. What do we mean by early testing? So to understand this we have to quickly see what are the phases of testing. Phase of testing. So the first phase of testing is unit. The second is integration. The third is system. And the fourth is UAT. So these are the 4 phases of testing which you have to perform. So now let's say there is some issue which is caught in the unit testing phase. Now since it is already caught in the unit testing phase, it will be rectified and it will not move forward or move downwards into further phases of testing. But let's say there is some issue which got caught in the UAT phase. Imagine the kind of rework or retesting which will be needed, because since it got caught in the UAT, it would have to be fixed, and then all other phases of testing would have to be performed, like unit again, integration again, system again, and then UAT again. So a lot of rework increases. That's why it's very important that we find out issues as early as possible. So as a tester, your aim should be to find out issue and avoid the downward flow of the defect. This is a terminology which you'll be requiring to use and also hear a lot of time in testing, downward flow of defect. So that's what early testing mean here. I'll quickly go back to the slides. So early testing is important so that this issue or bug is not flowing downward and is not affecting your system and saving a lot of time. Talking about the fourth principle, which is defect clustering. What is the meaning of defect clustering? So it means in a particular software, there are few sections which has more defects than other sections. So as tester, you have to know that and you have to focus on those areas more and fix them. So this clustering of defects can arise due to various reasons, maybe due to somebody's mistakes, or some domains are like that which has or which tend to or which is prone to having more defects. So you have to understand and know that areas or clusters and work more on them and work on them first before other sections so that the system can be tested well. Let's move forward and we talk about another term, which is pesticide paradox. Now this term also you will be hearing a lot when you will be working as testers, because what this term means is, if you continue to test in a way you have been testing, you will not be able to find out new issues. That is, if you're following a particular method of testing, or if you're following particular set of test cases for testing a particular software, and you're not changing it or updating it, you'll not be able to find out new issues. As simple as that. So you have to keep applying or updating your test suite, or applying new methods or applying new ways of thinking, so that you can try to break the system and be able to find out undiscovered issues. So you remember, one of the objectives of testing was to find out yet undiscovered errors in the system. So as pesticide paradox, if you really want to find out issues which are not yet discovered, you have to change your ways of testing. So that's about the fifth principle, which is pesticide paradox. Let's talk about the sixth principle, which is testing is context dependent. Yes, as testers, you have to know that different domain of software or different kinds of software need a particular type of testing. So if a particular system is an e-commerce project, let's say, let's understand the pages of an e-commerce project. Here we go. So an e-commerce project has following pages. Let's say registration, login, home page, product listing, product description, cart, payment and order pages. Now you know that how the flow of e-commerce project work, and you have to test it accordingly. But if you're testing a banking application, you have to know how to test it. You have to test as different logins. You have to know the backend panels of banking software. Here you have to know the backend panels. Here the backend panels can be customer support panel, or order panel, or inventory panel, or user details panel. But in the banking, there will be different panels at the backend. Maybe the customer support, again, finance admin panel. There can be business admin panels, or there can be a mutual fund or different sections. So each context is different from other, and you have to know as a tester what you are testing. So that's about testing being context dependent. Let's talk about the last principle of testing, which is absence of error fallacy. What does this mean? Let's say a software has been developed and it is not even serving the purpose for which it has been developed. So even if you do a lot of testing, find out a lot of issues, it's of no use. So again, the definition of testing, if you remember, second pointer, we do testing to make sure that the product or your software is matching the exact client requirements. So here we go. So if we are not sure that the software has been built for the purpose for which it was started, or maybe let's say if there's a coffee mug and it is not being used for drinking coffee, what's the use? No use, right? So similarly, if the software for which it has been developed, it is not serving that purpose, and we find out 100 issues in the system, it's of no use. So absence of errors. You have to make sure that the system is actually meant for the purpose it has been developed for. So these are the 7 important principles of testing. Number 1, testing shows presence of defects. Number 2, exhaustive testing is impossible. Number 3, early testing is very important. Number 4, defect clustering, knowing about defect cluster. Number 5, pesticide paradox. Number 6, testing is context dependent. And number 7, absence of error fallacy. So these are the 7 major principles of testing. As tester, you must know them, you must revise them, you must understand the core of these principles. Then you can move forward with learning more technologies, more concepts and terminologies of testing, so that you can become a very good tester. So that's all from my side on today's session. The next session will be about SDLC and STLC. Thank you, everybody.